Hello, hello, hello. Thank you for coming, everyone. My name is Deep Kapadia. I am the Executive Director for Delivery Engineering at the New York Times. I'm here with my colleague Prashant. Uh, we're here to tell you a story about the New York Times. We decided to move to the cloud a couple of years ago, and we went through a really interesting journey. And if you're thinking about what the New York Times is doing in the cloud, we're traditionally a newspaper, but today we do a lot more things besides publishing a newspaper. And I wanted to show you a 1-minute clip of some of the things that we do on an ongoing basis. And let her rip. You can find the mouse cursor. Yep, there you go. Perfect.
Hey,
Hey,
sorry. So I got the folks here at Kinko's to let me use the phone.
that's it for the daily. I'm Michael Barbaro. See you tomorrow.
Okay, sorry. So, uh, sorry, transitions are a problem. Uh, so you saw a lot of things in that video, and I think what stands out is the fact that the way we produce and showcase journalism today is very different from what we used to do like maybe 20 years ago. So there's a lot of products that you saw, or a lot of things that you saw in the clip, and it is important to know that we've transformed from being a newspaper to being a full-fledged media company, which requires a lot of technology and engineering prowess to actually continue running. And we continue to experiment with newer ways of telling stories. So, like you saw Snapchat Discover, augmented reality. A lot of those things require like a lot of engineering manpower to run, but also a lot of compute, a lot of understanding of how to serve the content at large scale. So I want to talk to you about like what it means to do that, and why did we go down the path of moving to the Google Cloud? What did our plan look like? How did we how did we go through some process and culture shifts? Some of the lessons learned, and also a little bit about what we are working on today. So, so this is where we started. So if you were to look at the image here, this was our first ever homepage in November 1996. And, and if you can read the line at the bottom, it says, please open your window to the width of the line of this text. So clearly not a responsive design. It was mostly a GIF with an image map where you could click through into stories. And we've come a long way from there, as you saw in the video clip. Today, the website, nytimes.com, the main website, runs on GKE. It's a managed Kubernetes platform by Google. There have been a lot of talks, including the keynote about it. We embraced a lot of cloud-native ways of deploying and building stuff that allowed us to move faster. And we shut down our data centers this year in April. So we don't have co-located data centers where we run our website out of. And this is what it looks like today. The homepage, you don't need to open it to the width of the line of some text. We are responsive, like it'll resize. But the homepage is a fairly complex mishmash of content. And also, we have our article pages, our interactives and graphics. That's one we did for the 2016 election. So for special events, we do special apps to tell stories in a specific way. There's newer products that we've built along the way, like our cooking app. We've always had recipes in the newspaper that we brought together and built a cooking app where people can share, annotate recipes and things like that. The Crosswords app has a life of its own. It is our highest grossing product. And it's a very popular one as well. So all the things that I'm talking about require a lot of things behind the scenes. We're talking about APIs. We're talking about APIs that manage our content management systems that the newsroom uses to actually write and build these experiences. The consumer revenue side of things, where we manage subscriptions and make sure that we're also reporting on those. Our archives are a great source of research for institutions and students and professors and researchers alike. And then lastly, our mobile platforms, our mobile apps. The way people consume content is changing, so mobile apps are a ubiquity for us. But there were a lot of challenges to get from where we were to where we are. As of 2 years ago, the challenges listed here are pretty much challenges that a lot of technology organizations face as the landscape is shifting. The New York Times had a website in 1996. Surprisingly, it's been in existence online longer than Google has been. So we had an IT team that was actually just managing that website, which was a very simple GIF that someone would upload and an image map that people could click through, into a larger infrastructure team, many product teams. Organic growth sprouted lots of products and platforms. Everyone was doing things a little bit differently, sometimes significantly differently. And that's difficult to scale, especially when people start doing things differently. It becomes very hard very quickly to move faster. You tend to build silos and you tend to work in silos, and anytime you have to work across silos, it becomes very hard for you to move. As a result, a lot of the apps that we were trying to push out were basically a spaghetti or a mishmash of architectures that people put together to work around some of the constraints, because the IT infrastructure team was very small and it couldn't scale very fast. And the big problem we had is that we had to move very fast. I mean, we wanted to move at the speed at which Google, Facebook, and our other competitors are able to move at today. And that was becoming harder and harder. So we decided, and we talked long and hard about this. So what we decided to do was form a team that would evangelize best practices and also build common tooling for engineers, kind of like what Google does for all their other clients. But we decided very early on that this was not a team that would run your infrastructure for you. So if you were a web app, you couldn't lob a web app over the wall to an infrastructure team and say oh, please run it and scale it for us. We would ask teams to do that, but we would provide the teams with the support and the tools needed to do that. And we would help teams build the operational maturity along the way. And we would manage some common tooling along the way. So everyone needs to build and deploy applications. Everyone was talking about continuous integration, continuous deployment. You need something to do that. You need something to manage secrets. You need You need a common way for you to build stuff. You also need to build maturity as a part of your site reliability uh, engineering practice. So we would work with teams to uh, help them understand SRE practices, build tooling, monitoring, etc. And also a lot of test automation, which means building tools for testing and integrating those tools with your CI/CD pipeline. So that was sort of the mandate around which this team was formed and evolving over the course of the last 2 years. And I'll let Prashant talk about how we actually implemented some of the changes that I just mentioned.
Thanks, Deep. So as Deep mentioned, there were challenges we were seeing, and we formed delivery engineering to solve that problem. Now I'm going to talk about how we saw migration as an opportunity to solve those challenges. And I'll walk you through like what services we chose from Google and the strategy that we implemented for cloud migration, and also we'll look at our migration plans. Sorry, it took a while for that to pick up. So what we want are the things that we saw from our challenges, and what we chose is what I'm going to talk in detail. So what we needed was a highly scalable and reliable infrastructure. Our scaling needs are spiky at times. When we send out a breaking news alert, we have to scale up pretty quick to serve that traffic, and it could be like an event-based scale up. The scaling needs were like based off of events too. Like if we were to if we are hosting an event like elections or Olympics, maybe any special event, we had to scale up our infrastructure. For that, what we needed is to build apps that could rely on reliable infrastructure like GCS, BigQuery, Bigtable, and GKE. They all have published SLAs, and they're pretty much reliable. So we chose to work with these services that are managed by Google. And Deep mentioned that we wanted to be fast. The way we wanted to be fast is by bringing autonomy in managing environments for the developers. Over the years of experience, what we found is developers are more knowledgeable about managing their application in case of an outage or shipping that huge configuration change that it could make a lot of impact. So what we chose was to use GCP projects as a tool to provide that autonomy. And give developers the full access to their own environments and help them manage their own infrastructures in production. At the time when we were in our data centers, we saw how containers could help, maybe for scaling or maybe for making the parity between your dev stage environments. And we wanted to adopt container technology as a main scale way of deploying and building and deploying applications to production. At the time, we were evaluating container orchestration services like Marathon, Mesos, Nomad, and Kubernetes. In the end, as a company, we decided to adopt Kubernetes as our container orchestration service. But if we were to build and manage Kubernetes infrastructure for the entire company, then the delivery engineering team, which is a small team in number, would have been in dealing with just managing the nodes and clusters and patching them and whatnot. So when Google came out with managed Kubernetes service, which is GKE, it was quite easy for us to double down on GCP and GKE and rely on Google to manage our infrastructure. That is the Kubernetes infrastructure. So what we were looking at was a true engineering partner who could provide services and support for building applications, and as well as even run those applications for us. So that's how we chose our GKE services, what we want to work with. But we had to build up a strategy for migration. The way how we saw our strategy was to build, or it's not just like lift and shift, but lean onto the shift more. I mean, shift the processes that we were working with, that is our culture, and the tooling that supports this migration. So we wanted to shift the process, culture, and tooling. So shift in processes, as I mentioned, we gave GCP projects as a way to provide development teams an autonomy in managing their own infrastructure. What that really meant was teams would know what they own and in their GCP projects and their destiny of those services too. We moved away from this culture of having an ops team that would manage their applications in production to developers owning their services end to end. So that's a culture shift that we did. Traditionally, we were working off of a ticket-based system, and we wanted to change that by building automation that are common across multiple teams and projects by just using off-the-shelf tools like G-Cloud and kubectl or kubectl, whatever. And we wrote documentation. We built a lot of centralized documentation and step-by-step guides to onboard teams to the automation that delivery engineering built, and in helping them manage their infrastructure. So we basically moved away from ticket-based traditional infrastructure way of handling tasks that are common between application deployments to much more self-service model of building automation that solves these common tasks. So as we were migrating, we also saw that we were going into a different land altogether from data center to GCP. Not every team was aware of how Kubernetes worked or what GCP services could do. So we had to build a lot of training. We engaged with Google and educated a lot of teams around how Kubernetes GKE could be employed to build and deploy their applications and so on. So what we did here is build those transferable skills. The culture shift is, yes, there is projects there. There are applications that are building, but we needed to build that consistency in the way how these teams could work with those environments. The way how we did that was just training. Like we build those transferable skills on teams. So if an engineer were to move from one team to another team, they would be comfortable in understanding that environment. The culture shift in the way how we manage our CI/CD processes. So I gave a little bit of an insight into everybody gets a project and they're off their own and they can configure whatever they want. But the way how we wanted to bring consistency in managing these environments is by building automation around CI/CD. So we adopted Drone, a container-based deployment tool to help deploy applications. The shift that we came out of is we were not setting up build bots with a config management tool with Jenkins, and teams don't have to go back and forth. All we have is just a YAML file where their pipeline is described as code, and we, as delivery engineering team, provided that YAML file as a template. So teams could extend that template and deploy their app. So we made a shift from writing configuration management code for building build bots and completely on container technology with Drone. So Drone and GitHub are integrated, and if there is a Git push, then Drone kicks in and deploys to wherever it has to. So secrets, it's a big topic. When we were in our data center, there are various ways teams use to manage their secrets. It could be Git crypt, or it could be Puppet, Hira YAML. So there were various ways, and obviously that led to secret sprawl. We wanted to tackle that by deploying Vault, HashiCorp Vault. Vault is a single tool that had been integrated into our GitHub and Drone. So every team gets a secrets backend space for Vault. We call it namespace. And teams can write their secrets depending on their repositories and push those secrets into their namespaces without having to model with other teams' secrets. So with Vault, today we have about like 75 namespaces where, and the way how we integrate it is if teams have to build and deploy new environments, Vault can completely take care of these secrets and deploy to those environments. So we've adapted Vault, and the policies of managing Vault is also put into Git. So we use policy management as code with Vault now. When we were in our data center, we used to have a physical networking routing equipment like NetScalers, and also we had a varnish monolith layer where we used to create pull requests, and it was becoming like a monolith, huge monolith that was taking our routing layer into a unmanageable state. What we did was we adapted Fastly. We made that routing layer into much more modularized components that teams can own and manage their own routing routes in terms of writing a VCL code. So we moved away from this ticket-based model of changing routing paths to modularizing and making it a code way of handling the routing logic. Adapting Fastly, we also achieved I would say a much more important feature is what we did during the migration. We wrote logic to split the traffic to applications in GCP, and by a percentage basis, like say 5% of the traffic would go to GCP applications, understand how that traffic pattern would affect that application, and learn about these services in GCP, and move on and cut over to maybe 50% or 70% and test out how the app behaved with the modifications that we were making to fit GCP. And gradually we cut over from data center to GCP with Fastly. Costs. When we move from a data center to cloud, cost is an important thing. For us, all of our operational costs in the data center were budgeted in a single budget. So teams really didn't know or had to look into the operational costs of each application. But when we gave GCP projects, teams had to have visibility into how much resources that they're using in the cloud. What we did is delivery engineering built a budget bot that basically alerts teams about alerts team about the budgets that they have set for the projects. So people can set budgets in a YAML file. As you can see here, they're setting alerts for 10%, 25%, or 50%, or 75%. So the bot basically sends a Slack notification when the GCP project hit those budgets or thresholds. So we just codified or made budgets into code. Overall, our shift in the way how we use tooling and culture now looks like this. Most of our work is GitOps-based, GitHub-based. You have your code, pipeline as code, and infrastructure as code with GKE and GAE. And also managing your secrets and managing your policies for secrets is also now infrastructure as code is tied into that notion. So basically, if you're a developer, all you do is git commit, push, and drone does cube apply onto the GCP projects and pushes code into the environments. So it's much more simpler and consistent across the projects. So now I talked about the services we chose, the strategy we used in the way of how we shifted our data center applications into GCP. And I'm going to talk about how we executed our migration. So when we were strategizing and developing tools, around a year and a half ago, New York Times decided to shut down our data centers by Q1 of 2018. And we didn't extend our leases, so we had to meet those deadlines. That's the situation we were. Basically, our planning was on 4 major components that I will hit, which is networking, data, application, and monitoring needs that you would see. So those are the 4 pillars that I will cover as a migration and transition plans. So, like coming from a data center mindset, you all would have had this experience. Most of your apps need physical network in a way how they connect with each other. But as I mentioned, we were going into a plane where all applications are going to be in individual GCP projects. And we started trying out fewer networking models to solve for the connectivity. The main connections that we needed were our data center to GCP project by a GCP project in a hub and spoke model where there would be a direct connection from a centralized hub project where we would host our infrastructure services like DNS and expand that with VPN tunnels to other GCP projects. We experimented with that, and then we quickly realized that there are limitations on how many VPN tunnels that you could connect with on a single GCP project, and we couldn't move forward with the hub and spoke model. And then we started looking into VPN mesh networking to connect all the GCP projects with each other whenever there is a connection that's needed with VPN tunnels. Even that didn't scale well because it was becoming a lot of overhead for our team to maintain these connections and make sure the VPN tunnels are healthy and whatnot. So finally, we met with Google. We went through our needs. What we needed was a way to have our data center services exposed to the services that are getting deployed in GCP. So we achieved that using cloud endpoints. How many of you here are aware of cloud endpoints? Have you experimented with cloud endpoints? That's quite a few. All right. Cloud endpoints is a proxy that is built by Google. I would highly recommend. There are not many people that raise their hands. I'm aware of the cloud endpoints. I will raise mine. But one thing I would say is this proved to be a solution that we could use. I would highly recommend looking at the way how cloud endpoints can be deployed. But what it is generally it's a container, Nginx container that Google provides, and it has authentication. It can help you provide authentication against your services that don't have auth right now. So we use cloud endpoints to deploy in our projects, GCP projects, to have connection between project to project on a zero trust network. And that is the Google's way. The Google's prescribed way is to implement TLS encryption everywhere and be on zero trust network. We also deployed the same cloud endpoints. Google calls it as extended service proxy. We deployed that extended service proxy in our data centers to expose the services that are in our data centers to the project and services that are in multiple GCP projects. So that's how our network had transformed from a physical VPN network to a zero trust TLS encrypted based network. Also, we started moving away from firewalls. We rely on IAM roles to limit accesses between services. Data, not all of our migrations were dump on load. What we did is we started syncing data to GCS bucket and migrate our data to services that are managed by Google, like BigQuery, Bigtable, Data Store, Cloud SQL, and Spanner. It required a little bit of rewriting, but we first migrated our data, syncing them into these abstractions, and we started cutting over slowly. So not all were dump and load, but some of them were. So as I mentioned, our strategy was to use GKE, GAE services that are managed by Google. In our planning, we made sure that most of our apps have migrated to those abstractions than going into a VM-based model where teams have to manage their VMs. This particularly helped us in the migration because teams were just focusing on the features and Google was managing their infrastructure for them. So the transition was much faster for us. And what they did was by providing that consistent automation that Drone gave, we converted all of our apps to fit into GKE, GAE model and 12 factorizing them. Like I said, we standardized our pipelines and we used Google Deployment Manager and Terraform to set up the basic infrastructure that is needed before the deployments began. How many of you here are working with more than one monitoring logging tool here? Wow. That's nice. Cool. All right. Usually, teams often ask for that specific monitoring tool that they like. And in New York Times, we ended up having a slew of monitoring and logging tools. As part of our migration, we wanted to reduce that number. What we didn't have is a default or standard way of setting monitoring reports or dashboards for alerts. So what we started doing is to rely on Google Stackdriver for setting up that basic monitoring and alerting that we had to provide. Today we have Slack and PagerDuty integration with Stackdriver, and every application has a basic dashboard that we could any team member could go and look at and understand their SLIs. So I talked about a lot of strategy execution. It's all great, but what we noticed is teams are at various levels of operational maturity, so we had to up our game over there, and I will hand over to Deep to talk about operational maturity.
Something wrong with this?
Yes.
So yeah, like Prashant talked about like the process of the migration itself, but a great part of this was building operational maturity into our practices and and on the teams that were actually going to build and maintain these applications. So we realized very early on, as Prashant mentioned, like not all development teams are at the same level of maturity. Like we had teams that were absolutely thrilled at the prospect of being in the cloud and like having all the autonomy and wanting to build everything from scratch versus teams that just wanted to build their little Node.js app and just like have it deployed somewhere in the cloud or just write application features but not really worry about operations. So I think we had to level set very early on with a lot of these teams. And we realized that during the migrations, a lot of these teams would need a lot of support. So Prashant mentioned all the trainings that we did, all the documentation that we wrote, like, you know, setting up the right level of support was very, very important. And one of the biggest things we talked about with teams was being on call, like making sure that, you know, we are giving teams a lot of autonomy to run their infrastructure in the cloud, but at the same time, it comes with some level of responsibility. The level of responsibility is around managing costs, also managing their uptime and their SLIs and SLOs on an ongoing basis. There was not going to be a central infrastructure team or a centralized system team going forward to actually manage the uptime for their apps and also be on call for those apps. So one of the things we did was every time someone someone decided that they were going to move to the cloud and they came up with a plan, we would kick that off with application readiness reviews just to assess where the team and the application are from a maturity standpoint. It was very important for us to do. So we started doing it with certain teams, and then other teams just jumped on it and said, oh, well, we also want to move to the cloud. Like, can you help us assess where we are and what we need to work on? And like, the idea was to identify gaps, not just from a technical standpoint, but also for us to understand, for our team to understand where we will need to provide support and how much support will these teams need. We also instituted regular office hours where people could come and talk to us about random questions. But at the same time, what the office hours did was it served as a community building exercise of sorts. Like people from multiple teams would show up and talk about their issues and then find solutions to each other's problems as a part of it, which was excellent because that sort of took us out of the picture and like the teams were actually talking to each other. And also sort of put our engineers in front of the Google technical account managers and like the Google customer engineers that were embedded with us for the course of the migration was really, really helpful. Thank you, Jim, Rami, Asher, very much. So, and of course, like, they were there. It was a shared fate for both us as well as Google. So they were there to support us during our major launches, during our major migrations, etc. And just before you decide to switch over to production in the cloud, let's do a production assessment. Make sure that you have all the things that you need. Make sure that you're ready. You're like for a calamity, or like in case you have to fall back to the data center for a while, what the plan for that is. So just doing a production readiness review was very important. We read this book, right? Like this is where most of our ideas came from. I wish we had written that book, but like we didn't. Yeah, like the idea was evangelize reliability as a feature. Like to us, it was very important that people understand that all the features that you build into your product are great, but at the same time, if you do not prioritize reliability of your apps as a feature, it can all go to waste very quickly. Like it only takes like 4 spinny wheels on an app for me to uninstall that app, and I'm guessing a lot of other people are maybe as impatient as I am, or maybe a lot less patient than I am. So to me, it's very important that reliability is considered a feature, so it's not something of an afterthought that you think about. And that was a big culture shift where teams started thinking about building more and more reliability into their apps, monitoring their SLIs, and like tracking their SLOs, etc., and like sharing them across the board. So like if a team knew that it was a dependency for many other teams, it was very important for them to build their SLOs and share it with other teams. That's something that we did through the course of the migration. We worked with Google's customer reliability engineering team. Nick is here. Thank you so much for all your help. They came in, trained some of our teams. They also provided us with a template of assessments that we allow that we work with teams on, and say like these are some of the things that you need to think about when you're trying to build more reliability into your applications. And allows us to have the conversations that the CRE team had with us very, very early on in the process. And then, of course, like as a part of the assessment, you can score high or low on certain aspects of your reliability matrix. And we make sure that the work that you need to do to build more reliability into your applications is tracked on an ongoing basis, so that it doesn't get lost. This is all work that comes together, and when it comes together, it's really nice. And I mentioned being on call. This, to us, was probably the biggest culture shift. So, on-call freaks people out sometimes. Like it used to freak me out. It doesn't anymore, because we have built a lot of maturity around on-call. But the initial nervousness is very hard to overcome, and we had to go have conversations with a lot of teams and a lot of engineers who are very, very nervous about what happens if I get called in the middle of the night and I don't know how to fix the problem. So the idea is to build more confidence in your processes so that your engineers, your developers can feel more confident when being on call. We ask teams to develop playbooks, runbooks, solutions to common problems that could be shared across the board, perform war games, which is site-outed simulations that people can work through, and actually build more confidence in their abilities to support an application when they're actually going on call. And it continues to be an ongoing conversations with teams to build more and more operational maturity. So some of the lessons learned through this whole process, as Prashant mentioned, was do not try to replicate your data center setups in the cloud. Sometimes it'll work, sometimes it won't. Be very, very aware of what it means to run in a public cloud, and what are some of the constraints it comes with, or what are some of the constraints of your data centers that may not be constraints in the public cloud? Our networking journey was actually a very, very good learning example for a lot of people. We tried our best to work against the fabric of Google, and that didn't work out. It was just not the way Google wanted us to build apps, and which is fine. Like, Google's not a, I personally would tell my team, like, Google is not a vendor for us, they're a partner. They've done this. They've actually figured out how to run applications, services, and sites at scale. This is an opportunity for not just them to learn from us, but us to learn from Google as well. So treat them as a partner, figure out what are the best practices for your cloud provider, in this case Google, to actually run your applications there. Review your application architecture, connectivity, dependencies. Like, there were times when we had an app running in Google as well as our data center with certain downstream apps using the Google side of things, certain downstream apps using the data center side, or an app that didn't have enough confidence in their GCP setup, still having the data center as a fallback, and then gradually increasing the traffic as they built more maturity in the cloud. So continue to load test. The assumptions you make when you're running in your data center may not hold true when you're running in the cloud. You may need more compute, you may need less compute, you may need more memory. Like, things like that are important, so continue to benchmark your applications during the course of the migration, or in general, it's a great thing to continue to benchmark your apps through course of releases and deployments, etc. One of the things that we did early on was manage a centralized launch calendar. So teams were aware of their dependencies and were always aware of when their dependencies would be moving to the cloud, or when their dependencies would be ready in the cloud. So they could actually coordinate with their dependencies, or the depending systems would be able to talk to their dependent systems. Again, I talked about the CRE engagement. It was invaluable for us to have access to Nick and his team, and it continues to be invaluable for us. It's been amazing for us to interact with them, learn from them, and bring their practices back to the teams that we work with. In terms of what's next, we want to continue educating teams, educating ourselves in SRE best practices. We want to employ those across the board. So for that, we want to build tools, instrument metrics in a common way, so that we're always talking the same language. We want to build organization-wide SLO dashboards, so that we're always aware of what's going on. Observability is important to us, especially a news site that relies on very high uptime. News cycles are spiky. News can happen anytime. We want to make sure that we are building a lot more reliability into our application, so we can provide the most benefit to our readers. We want to, I mentioned test automation very early on. It's a fairly new practice that we are adopting, but at the same, what we want to do is make sure that automation is a first-class citizen in all CI/CD pipelines that we build. So provide tooling for us to embed functional tests, end-to-end tests, load tests within our CI/CD pipelines, so we can run them as a part of every deployment or on demand. And while we do this, we want to celebrate our successes. So that's one of the things we are doing here, is actually talking about some of our successes. We've learned a lot from it. We want everyone else to learn from it as well. And if any of this sounds interesting to you, please come join us. We are hiring. We want to work with smart people who we can learn from. So it's always interesting. We always talk about our experiences on the open blog that we publish. So yeah, that's pretty much it. Okay then. Thank you, everyone. And we are here if you want to talk to us. Come talk to us. There's other people from the New York Times over here, over there. Please come talk to all of us. Thank you.